Hello, today's all about making flexible shapes. Now, what are flexible shapes? Well, this shape's a little bit flexible, maybe. This shape isn't flexible at all. I can't do anything with it. And this shape over here, oh my goodness. Oh my, oh my, oh my, look at that. Oh my goodness, it's very flexible. In fact, it's so flexible, it's tied itself in a knot. There we go. Oh, we've done it. There you go. You've seen that shape before. It's called a cube. I'm going to change the video and turn it around the other way so that you can see all the other shapes that I've got, that I've just shown you. You can see it a little bit more easily than in front of my face. Just going to also make it so that other people can come and watch, have a watch party and invite more people to the session. Here we go. And start. There we are. Now, how can I make it so that you can see what I can see? There we are. We're both looking at the same thing now. So get your grown-ups to make you lots of sticks. Then together you can work out, there's a special activity and you can get them to download the activity. It's in the description. And in that activity, there's lots of shapes, and this is one of them. And you can make it, you can work out how many sticks you need, what shapes you're making, and give them a name. These are triangles. And then underneath, we've got a square. And then you've got other different shapes. So you've got this other shape here. This is made all out of triangles. And then we've got the other shape, which I just managed to untangle. And it's a cube. Now first of all, just to let you know, these are what we call the skeletons of these shapes. They're not, if they were proper shapes, as in they were proper 3D shapes, solids, you wouldn't be able to see, whoop. You wouldn't be able to see, whoop. What's happening? Wait, what's going on here? That wouldn't be happening because it wouldn't be changing shape like that, because there would be maybe a bit of cardboard or something in there. But this is showing us just how flexible the shape is, how rigid the shape is. So if would you build a building like this, if you were building it out of steel, or would you build it more like this one, because you build that one and you have a go and see if you can get it to collapse without breaking it, obviously. See if there's any way you can place it where it collapses, whereas this one, blue. So when buildings are made, they aren't just made, they're made this shape mostly. Not all buildings are made this shape. They're made this shape mostly, but there's other stuff going on to hold them up to make sure they stay upright. So that's where the engineers come in. The engineers know what they're doing and they build the houses, and the house builders and the building builders and the structural engineers, they know what they're doing. So they make sure that the houses are strong and they stay upright. So what you can do is, we'll come to that in a minute. We've got to do that yet. This is the other shape to make. Now that shape, again, you can have a play with it and see. So we saw this one stays rigid. This one can collapse, and you can find out all the other different shapes that it makes. You can just play with it. And then you can draw the shapes as well. And maybe you can combine different shapes and make lots of fun things and talk about how many faces. So that would be how many squares. For this one, that's how many faces. You can talk about what shapes it becomes. That's a rhombus, like that, when it's a little bent like that. How many faces this one has, what is the name of the shape, how many edges it's got, how many vertices it has. Those are the pointy bits, so the edges are the lengths. The pointy bits are the vertices, one vertex, many vertices, and then the faces are the shape on every face, the triangle or the square or whatever other shape you make. Now this one, let's see what happens. If we put it down that way, stays upright, no problem. So let's move it that way. So, oh my goodness. What if we put it on this one? What's going to happen if we put it on this one? If I let go? Oh, look at that. All right, what about this one? Oh, is it going to do the same thing no matter what face I put it on? If it isn't placed on the square, it collapses, but it doesn't collapse. Whoopsie, that one's my strings. I've had a fancy way of putting the strings together, and I'll tie them properly next time. If it isn't sitting on the square, it collapses, but it doesn't collapse down to a straight line like this one can. See if you can make it collapse down to any other shape than this one. So those will be all the games that you play with it. So just have at it. Just go and play. Let me just stop sharing so you can say hello. There's it. We go. Okay, there's my cube. Look. And yeah, just play with the paper sticks. There's lots of links in the description for you to go and see on YouTube. There's another video on YouTube that's not aimed at early years, but it might be interesting to watch. It's quite a nice one just to see the shapes. And there's how to make paper sticks. And there's also a link to the sister activity of this, which is the collapsible cube. Please do take pictures and send in the pictures, because Tandy, I thank Tandy, Clausen May for making this activity, and she is looking for pictures to put in an article that she's going to put in a magazine for teachers. So that would be amazing if you could send in pictures. Thank you very much. And now let's see if anybody's joined us. Oh, Henrik, hello. A simple but fun thing to do. Yes, indeed. Oh, Hamiltonian paths. Okay. Thank you, Henrik. That's an idea. I will pass that on and look into doing that. Nice one. Thank you, Hendrik. And Barbara, hello, Barbara. Thank you for joining us. So thank you, everybody, for coming to play with the paper sticks today, making flexible shapes. Please do have fun. Tell us what you've done, put in comments about what you've done, and send in pictures. That would be amazing. Thank you.